Continuing with factoring, as a quick review, whenever you factor, there are the two questions you have to ask. First, is there a GCF? And after that, you see how many terms there are. And right now, we're still looking at the situation where we have two terms, or what we call a binomial. And we've already covered the first option, which is difference of squares. And now we want to look at the second possibility, which is sum or difference of cubes. Now the sum or difference of cubes, let me write down, we have two pretty long formulas that we use if we have a sum or difference of cubes. So for instance, a sum of cubes may look like this: a cubed plus b cubed. We can rewrite that as a plus b in parentheses, and then in a new set of parentheses, a squared minus ab plus b squared. All right. It's a pretty big and ugly sort of formula. Now we can also have difference of cubes, and you'll notice the formulas look pretty similar except just a couple signs have changed. So for instance, with the difference of cubes, we still have a and b here, but now it's a minus b. And then in the second set of parentheses, we simply add everything. So now let's look at some examples of how to factor if you have sum or difference of cubes. So say you're given this expression and you're asked to factor. You of course check the GCF and you realize there isn't any. And then you say there are two terms. Hopefully by now you realize it's not going to be difference of squares. First, there's no subtract, plus. Normally difference of squares, a lot of times you'll see an x squared there. As soon as you see an x cubed, then you begin to think maybe this is going to be sum of cubes. Now for sum of cubes, there's two things to check. Basically you say, can I cube something and have it equal x cubed? Well, yes, I can. That's x. And then you look at the second term and say, can I cube something and have it equal my second term? In this case, yes, I can, because 2 cubed equals 8. These are the only two things you have to check to see if it's a sum of cubes. And the nice thing is, when you check them, then you automatically determine your A and your B, because now it's like the X is going to be my A, and the 2 is going to be my B. So now I can go up here and use my formula for A cubed plus B cubed. So this says a plus b, which is going to be x plus 2, because x is like my a and 2 is like my b. And then it says parentheses a squared, which would be x squared, minus a times b, which is x times 2, or we'll just write it as 2x, plus b squared, since b is 2, and now we have factored using sum of cubes. Okay, two more examples. (4y cubed minus 4). We're asked to factor this completely. And here we go again. If you forget to check for GCF, then you will think this is prime. because if you tried to do the difference of cubes on this, it would not work. But once you see that there is a GCF, you can factor out the 4, which is a GCF, and then you have y cubed minus 1. And now we're going to look at y cubed minus 1 and see if that's a difference of squares. Well, I can cube y to get y cubed. If I look at 1, well, you know what? If I cube 1, I will get 1. So it turns out this is a difference of cubes. Now my y is going to be my a, my 1 is going to be the b. So when I factor it, I go and write my 4, and then I look at my formula, which I can still see up here. For the difference of cubes, it's a minus b. So it's going to be y minus 1. And then a squared, a is y, so y squared plus a times b, y times 1, or just y, plus b squared, since b is 1, plus 1. And then the last example I'll do quickly. Looks a little more complicated at first. 27x cubed plus y to the 6th. All right, we're asked to factor this. We first check for GCF. There is no GCF. We see that there are 2 terms, so we know we can either try difference of squares or the cubes. Obviously, the cubes looks like a better chance. So if I look at this first term and I say, is there something I can cube that would equal 27x cubed? Is there something I can multiply by itself 3 times that would equal 27x cubed? Well, if you look at the 27, I believe 3 cubed is 27, and then you've got the x here. So I believe if you cube 3x, it equals 27x cubed. And now I look over here. Now this looks a little interesting. Can I cube something and have it equal y to the 6th? How about y squared? Y squared cubed, what do we do with those 2 exponents? We multiply them. So as it turns out, this is a sum of cubes. The 3x is like my a, the y squared is like my b, and although we can't see the formula anymore, it's a plus b, so 3x plus y squared, and then in parentheses it's a squared. Well, that would be 3x squared, so it's 9x squared minus a times b, 3xy squared, plus b squared. Y squared squared is y to the 4th. All right, so it's a little more complicated, but not really that hard. So those are some examples of sum and difference of cubes.